Hi everybody, my name is Dr. Naraki and I'm going to be your professor for Calculus 1. I'm a full-time professor in the math department at Albright College and I teach calculus and all math courses at the undergraduate level. Now the purpose of this video is to give you a brief introduction to how the course is organized and what exactly is calculus. So let's start out with the course organization. So here's how the course is structured in Moodle. First of all, we have some course information. This is the video that you're currently watching. This file is an outline of what to do when you first log on to the course, so you should take a look at this after watching this video. This is the course syllabus. This contains detailed information about the course, how it's structured, and expectations, so you should read through this very carefully. This is a course calendar. It contains due dates for assignments and exams. This is an online version of the calculus text, so you can use this in combination with the videos to learn the material. You could also purchase a hard copy of the text if you want. Now down here we have solutions to odd problems in the textbook. I'm not going to collect problems directly from the textbook, but if you want to work on some additional problems from the text for practice, this is a good resource since it gives you the answers to those problems. And here we have an online course agreement form that you need to fill out when you first log on to the course. This is a forum that I'd like you to post some information about yourself so you can learn about your classmates and they can learn a little bit about you. Here we have some additional information about Albright support services. And then down here we have information about the WebWorks software that you'll be using to submit your homework. This is an introduction video to WebWorks. This is some additional information about how to correctly enter solutions into the WebWorks software. Take a look at that. It's an important document. Here we have a video about how to take timed exams in WebWorks. The exams that you'll be taking in this course are online and they're through the WebWorks software. So please take a look at this video very carefully. And then this is just an additional hyperlink to the WebWorks website. Here we have some additional tools. This is a nice online graphing utility that you can use to graph functions. And here we have a download for Adobe Reader if you need it. This is the best way to print the course notes. Down here is the communications section for the course. This is where I'll post course announcements, so make sure you check that each day. We have a questions forum where you can post questions about the course or homework problems, and your classmates can answer those questions, and I'll also take a look at them daily. And here we have the Zoom video conferencing software. This is what you'll use when we have our online video sessions. There's more information about how to use this in the syllabus. Now down here we have where the course material actually starts. This is the preliminary module. You'll notice that the material from this section, the videos, correspond to sections P2 through P3 in the recommended textbook. We have listed here student outcomes for this section. Now right here we have notes that go along with the videos. So it's a good idea to print these notes out and then you can use them as you're watching the videos. Now after you watch these first 4 videos, then you can do homework set number 1. And then the pattern continues like that. We have lecture notes here for the next section, an additional resource, the unit circle diagram from trigonometry. Then you can watch some videos corresponding to these lecture notes, and then you can do homework set number 2. Now further down here we have Module 1 covering limits and continuity. The videos in this section correspond to sections 1.1 through 1.5 in the recommended textbook. We have listed here student outcomes, and then once again we have course notes, videos, and then homework sets to do after you watch the videos. And then that pattern continues. Now you notice down here further, after you finish Module 1, and then we have our first exam. Now the date for that is posted on the course calendar, so please review the course calendar dates very carefully. This file right here just contains some additional review questions for this exam that you may want to work through. It also has answers that go along with the questions. This is just additional review material for you in preparation for exam number 1. And then you see down here we cover differentiation. That's our next module. Then we have our second exam. And then we cover applications of differentiation. Then we have our third exam. Now at the very end of the course, you'll notice we have finally our fourth module, and then we have our final exam. The final exam will be cumulative, and the date for that is also posted in the calendar section. So that's a brief overview of how the course is structured in Moodle. Now if you've never had calculus before, let's take a look at a few key concepts that we're going to be covering. Now consider this function that we have graphed here. This is the function y equals x squared. We have it graphed right over here. This is the Desmos graphing utility that we have labeled in Moodle. Now let's take a look at a particular point on the graph of this curve. Take a look at that point right there. That's the point 1, 1. Notice if I put 1 in for x, I get back 1 for y. Now if we draw what we call a tangent line at that point, we get something that looks like this. So there you see that line. Well, it looks like what we would call a tangent line. It looks like it's tangent to the graph of the curve at this particular point. Now, so what that means is that very close to this point, the graph of the original curve is behaving just like the graph of that tangent line. If you're a particle moving along that curve, very, very close to the point 1, 1, you wouldn't really be able to tell a difference between moving along the curve y equals x squared and moving along the tangent line. Now, at the point 1, 1, the slope of this tangent line, you'll notice if I look at rise over run, the rise is 2 and the run is 1, the slope of this line is in fact 2. So what that means is that if you're a particle moving along this curve, at the point 1, 1, your instantaneous rate of change is going to be 2. Think of that as like your velocity. Your rate of change at this point, if you were to continue along that tangent line, for each unit you move in the x direction, you will move 2 units in the y direction, so your change in y with respect to x will be 2. We call this the instantaneous rate of change at the point 1, 1 on that curve, y equals x squared. And this, in fact, is the value of what we call the derivative of x squared at the point 1, 1. So calculus, that's essentially the heart of calculus. It's all about finding rates of change of functions like y equals x squared at various points along the curve. And the rate of change is the slope of these tangent lines. Now, notice one other thing here. If we were to take this function x squared, and if we do a little trick with it, if we just drop that 2 down in front, we get 2x. Now you notice, if I put 1 in here for this x, I get back 2. That's actually the slope of the tangent line. Is that a coincidence? No. In fact, for any point along the curve y equals x squared, if I take a number and put it into this function right here, I get the slope of tangent lines. For example, if we look at this point up here, 2, 4, and I draw the tangent line through that point, you'll notice the tangent line, right there it is, it's that green curve. Let's see if I can drag that down a little bit here. So we're right there. Now the slope of that green curve is in fact 4. The exact equation is 4x minus 4. And notice we started with the function y equals x squared. We looked at this function 2x. Notice if I put the number 2 in for x here, I get back 4, which is the slope of the tangent line at this point. Okay, so this function right here seems to be giving us the slope of tangent lines to the graph of this function. We call this function 2x the derivative of x squared, and that's the heart of calculus. The heart of calculus is finding derivatives of functions and understanding what they represent. The derivative represents the slope of tangent lines, and the slope of tangent lines we interpret as being an instantaneous rate of change for a particle moving along that curve. So that's the heart of calculus, is this notion of an instantaneous rate of change and trying to calculate it by finding what we call the derivative of a function. So this being the original function and this being its derivative. So at any point along this curve, if I plug a value in for x, I get the slope of the tangent line, which we interpret as instantaneous rate of change. That's the heart of calculus. Now that's the heart of differential calculus. In this course, we're also going to study integral calculus. So let me explain a little bit about that. So if we consider the same function here, let me just take away those tangent lines, move this graph over here a little bit. Now, for integral calculus, we might ask this question. Suppose I look at this curve y equals x squared, and I would like to know what is the area bounded between the graph of the function and the x-axis. So, we might want to know what this area is. Now, there are very good reasons why we would want to know what this area is. There's lots of applications in physics for wanting to know the area underneath the graph of a curve. So we want to know what that area is. Well, suppose we take the function y equals x squared, and we find what is called the antiderivative of that function. Okay, so what's the antiderivative? Well, the antiderivative is going to be another function. In fact, it's going to be, in this case, x cubed over 3. So that if I take the derivative of this function, now the derivative, remember, that's another function that measures slopes of tangent lines, I get back x squared. So if I take the derivative of a function, I should get back x squared. This is called the antiderivative of x squared. Now we're going to go over this in great detail in the course, so if you're not familiar with this, don't worry. This is what we're going to be covering. Now, when you take the derivative of x cubed, if you've ever had calculus before, remember what we did with this function to get the 2x? What we did is we dropped that 2 out of the exponent, put it in front of the x, and then actually we subtracted 1 from up here. For this, we do the exact same thing. Notice if I take 1/3 x cubed, and I drop the 3 down, and I subtract 1 from the exponent, I get 1/3 times 3x squared. These 3's, the 3 and the 1/3 cancel. I recover x squared. This is the antiderivative for x squared. Okay, so how does all of that relate to the area? Well, as we'll see in this course, it's a rather amazing result. The way we can evaluate the area underneath the graph of the function x squared from 1 to 2 is by taking the antiderivative, x cubed over 3, put the number 2 in here for x, put the number 1 in here for x, and subtract those two numbers. So in fact, this area in here, that area, will equal, if I put 2 in here for x, I get 2 cubed, which is 8 over 3, minus, and then if I put the number 1 in for the x here, I get 1 cubed over 3, which of course is 1/3. So we get back 8/3 minus 1/3, so that is going to be 7/3. That, in fact, amazingly, is the area underneath the graph of
x squared and above the x-axis and between the lines x equals 1 and x equals 2. So it's this shaded area right here. It's a rather amazing result that you can take the antiderivative of a function, evaluate it at 2 points, and you get back an area bounded between the x-axis and the graph of your function. It's a really amazing result. So that's the heart of integral calculus, and that's what we're going to be studying later on in the course after we study derivatives. So that's a brief overview of the two key concepts that we're going to cover in this course.